Hey everyone, this is John Massey. This is for ECE 535. Uh, I'm in the process of moving right now, so I'm making this in Starbucks. The other videos that you're about to see were made in a hotel room as I'm traveling across the country, but my design project wanted to be in a railgun. So one of the projects did work, the other one didn't. You'll get a chance to see them both, but you'll get to see the one that actually did work in action. So it wound up being pretty cool. So basically, the fundamentals here is that when we went through magnetostatics and going through Gauss's law of magnetism and stuff like that, we want to getting to the point where we said a current carrying wire experiences a force, the Lorentz force to be specific, perpendicular to that of the wire itself, right? So that's what we'll get to see here, and hope you enjoy. Up into three pretty simple parts. The first one will just be the kind of a proof of concept for how this works. So if I was to take that battery right there, hook it up to these rails, the only thing that the direction really matters for is which way you want it to go. If you want it to go this way, then you would hook it up so the positive is on this end. If you would want it to come back this way, the positive will go on this end. So if you hook the positive up here and the negative here, current flows this way, right? Which through the right hand rule we know causes a force to go this way and actually propel this forward. So because I'm using magnets to mount this, I need a non-magnetic conductor, which is aluminum. This weighs about ½ ounce and turns out to be way too heavy to move with 24 amps. So because I actually don't have any capacitors or anything like that, I'm just going off of a battery hooked up to resistors. So that's kind of a limiting factor for me. But nonetheless, turns out this doesn't actually work. I would show you, but all you're going to see is sparks and that not move. It's going to be very less than entertaining. So we'll actually show you the one that does work. Lower tech, I know. Literally aluminum foil and cardboard. So essentially, same concept. Your aluminum foil is now your rails. And if I take this very small conductor, so I just basically took a coated steel nail, cut the tips off of it, put some neodymium magnets on it, and it winds up looking like this. And so, similar to what our speaker wire or our speaker magnets did down there, our permanent magnets actually help us when it comes to actually propelling this thing, because their B field decreases the amount of energy that it takes to actually move this thing. So, first off, for anybody who's curious, no, this doesn't actually roll on its own without this. But nonetheless, there it goes, right? So you can see some sparks because we have the positive over here and the negative over here. Current flows this way, force goes that way. So that's what happens when you don't have any initial velocity, right? So you got to be careful though, because as your magnets heat up, they do become less and less effective. They kind of start to break down, right? These are only 3/8, kids 3/8 diameter kids toys, so I can't really expect them to be too high quality. But nonetheless, that's essentially the concept of a railgun, right? I didn't build one that actually makes a giant flash and has some cool stuff attached to it, but there's plenty of videos out there that do that, right? But this is kind of just the general concept. That's the railgun. Unfortunately, one of the models didn't work. Super small scale did, but they're pretty interesting. The Navy has used these, has been doing research and development on these for years and years, and it's really perfect for them because we've shown that you need a ton of energy just to get anything of a noticeable size to actually work. And as it happens, their battleships and destroyers are nuclear powered, so they have tons of energy at their disposal without actually having to deplete any of their resources to do it. All they have to do is move a chunk of metal over to the rails, hook it up to a big hammer on a spring, and short it between the two rails, and boom, you're done, right? So super interesting, super cool, and it's just electricity. That's all it takes to actually move something.